The first bullet point of the kinetic molecular theory says that matter is made of particles. This includes anything that could be matter, you, the air in front of your face, the wood that makes up the cabinets in my room, any piece of matter that you look at on the submicroscopic level, too small to see with a microscope, is really made up of particles, spheres, that you cannot see. This is similar to how all living things are made of cells that you can't see. And if you could see them, you'd recognize that all living things have that underlying structure. All matter, likewise, is made of particles. It's important to remember here that cells and atoms are nowhere near the same size. A single cell contains billions of atoms. So don't get confused about the size difference between those two things. It's important that you keep those two things straight. Remember that. A single cell is made up of billions of atoms. That's how small atoms are. Scientists actually use the word particle whenever they're trying to avoid being super specific about what they're talking about. So particle can refer to single atoms, like you have up here in this picture, or it can refer to a couple of the same type of atom that are bonded to each other. Just ignore this part in the middle, not important for our purposes. Or it could refer to a group of atoms that are chemically bonded to each other to form something called a compound or a molecule. Down in the bottom here, the red and green Mickey Mouse ears actually represent what's called a water molecule. So there's two hydrogens in a water molecule and a single oxygen atom. But when we talk about the particles in this unit, I'll usually refer to water as a single particle, like so. And I'll just say, these are water particles. And when I say that, I just want you to keep in the back of your mind that that's a simplification, right? A water molecule actually contains 3 atoms, but I'm going to draw it as a single circle because I'm not really interested in the individual atoms for purposes of this unit. Take a second to consider what I mean when I say the word particle. I could mean a couple of different things, and it doesn't really matter for this unit. I could be referring to a single atom, or I could be referring to a group of atoms that are bonded together, and we call those molecules. Both atoms and molecules can be represented as single circles. So it doesn't really matter if I'm talking about an atom or a molecule. I'll still refer to both things as particles, and I'll draw them like that. The difference being that a single atom really is just one piece, whereas molecules, like water, actually contain several pieces. If I were to draw it out the whole way, a water molecule contains 1 oxygen atom and 2 hydrogen atoms that are sort of stuck on like Mickey Mouse ears. But for purposes of this unit, I would just call that a single particle and say that that's a water molecule, or a water particle is probably what I would refer to it as. So don't be worried about what I mean when I say particle. I could mean something that looks as complicated as that, simplified to something like that. And that's it for the first bullet point. See you in the next one. Finally, particles have different types of motion depending how much energy they have. So I want to show you the 3 types of motion that you might encounter as we explore this theory together. Particles all the way on the left over here, you can kind of see these little hash marks that are drawn. That represents vibrational motion. They're vibrating. So those particles are actually holding their position relative to one another. They're not moving away from each other. They're not able to slide around, but they are sort of shaking in place. If you heat them up, they will actually move faster, and they'll reach a point where they can actually sort of do this. I'm going to draw these curved arrows in here. It's not so much that they're spinning as that they're able to slide past one another, but we do refer to this as rotating motion. And this is like in a liquid. Liquid particles are free to sort of slide and roll over one another, and that's why liquids flow. And then in this last picture, this shows what gas particles move like, They have total freedom to go in any direction, and they move in fast-moving straight lines until they collide with something, and then they bounce off in whatever direction makes sense. So we refer to this as straight line motion. I know it's hard to see. So those are the types of particle motion that you're going to encounter as we explore this theory a little more carefully. When you're ready, move on to the second bullet.